You've been doing graphs for a good part of your math life. Well, we're going to up the game a little bit and we're going to take a look at specific key features of graphs. They go through these bullet points. These notes you have access to on the lesson plan, so you can make a copy of these notes. And also know that I'm going to go in order down these bullet points. These notes go in that order. So if for some reason you stop right here, you can pick up right here and we'll continue in order. And I guess let's get going, huh? The first thing to look at is the concept or vocabulary of independent versus dependent variables. And you guys can all read this stuff, so I'm just going to point out the big picture. You're used to having a t-chart with x and y, and then we've been putting the terms input, output, domain, and range on that. You can just add one more set of terms, independent, dependent. So there's a scenario here where it says an Amazon warehouse worker earns $18 an hour plus an attendance bonus of $50. So we get this equation, y equals 18x plus 50, where you can plug in the Amazon worker's hours and get out the Amazon worker's pay. So if I plugged in 15 hours, $320 worth of pay. Well, you can say that the $320 this person earned is dependent upon their hours worked. The dependent variable is always influenced by the independent variable. And the 15 hours worked is what led to the output, or the dependent variable, 320. So on the very most simple way to think about it, XY, independent, dependent. But a more realistic way is think about a scenario and one of the variables is dependent or a result of the other variable. Remember, I've just hit the highlights of this situation. You should take the time to read it and comprehend it more for your brain as opposed to just listening to me ramble. The next idea we're going to look at is continuous versus discrete variables. And you can read through these situations, but it's basically going to be telling you that if there's something that you can't quantify in partial pieces, then that's going to be a discrete variable. Now that probably didn't make sense to you, so let's look at it this way. If you wanted to keep track of how many dogs people owned, you know nobody is going to own 2.75 dogs. You just can't own part of a dog. So the variable number of dogs owned is a discrete variable. The example I used for a continuous variable is your temperature. You could have a thermometer that says 98 degrees, but a better, more precise thermometer could say 98.4, and an even better thermometer could say 98.397. So your temperature is something that doesn't have to be an integer. You don't have to have 98 degrees for your temperature. It could be somewhere in between. But you can't have in between 2 and 3 dogs. You either have 2 dogs or 3 dogs. So you can also, like I said before, go ahead and read through this stuff and have it make more sense for yourself. But that is the difference between continuous and discrete variables. The next thing we're going to look at is x-intercepts, forgot the T, and y-intercepts. Very easy. As you look at this graph, you know this is the x-axis and the vertical axis is the y-axis. So when you look at a graph and the graph is just traveling along minding its own business, when it goes through the y-axis, here's the y-axis, when it goes through the y-axis, we have a y-intercept of 0, 3. You probably want to see that. Likewise, as this line is traveling along, it hits the x-axis down here at -4. So at -4, 0, we have the x-intercept. It's a really easy concept. I'm going to zoom out here a second. It's a really easy concept. The x-intercept or the y-intercept is where the graph intercepts that axis. As we go on later and we start getting more applied problems, the x-intercept and the y-intercept are going to have a genuine and deep meaning in relation to the scenario. But for right now, it's just the location that the graph hit the y-axis, the location that the graph hit the x-axis. All right, we're moving along on through the list. Remember that list at the front of your notes. We're just trying to go down and make sure you get a little idea of each one of these. And we're now at this section right here, which has a lot of words, and they're all underneath the umbrella of what's called extrema. But extrema is just a fancy way of saying extreme or an extreme location on a graph. So if you look at this graph down here, it's just bopping along, again, minding its own business like most graphs do. And you see that you end up with some higher locations and some lower locations, higher, lower, along the way. Well, those are called extrema because they're extreme locations. This is an extreme location, and this is going to be called a maximum. Makes sense, right? Because it's a high spot. And D and B, these are going to be called minimums because they are a low spot. There's a maximum. Actually, there's a maximum too. They can happen at an endpoint, and there's a minimum as well. So some maximums are the highest maximum out there, like C. It has the highest altitude. It's the largest point or the highest point. So that's called the absolute maximum. Whereas A is also a maximum, but it's not the highest maximum out there, so it's called a relative maximum. D is the lowest minimum, so it's the absolute minimum. B is also a minimum, but it's not lower than D, so it gets the unimportant term of relative minimum, not the absolute minimum. By the way, Z right here, this ends up being a y-intercept because that's where the graph hits the y-axis, but it also happens to be a minimum. It's a relative minimum. Just like this spot over here, that's a maximum. It's not higher than that one, so we will call it a relative maximum. It's a lot of vocabulary, but it kind of makes pretty intuitive sense. Maximums are the high spots, minimums are the low spots, and the absolute is the absolutely highest and absolutely lowest spot out there. These items are also going to have an important role later on when we're doing problems applied to real scenarios. Okay, we're cruising along. We've gotten through all these bullet points, so now we want to talk about domain and range and an appropriate domain and range for a scenario. So we're taking a look at domain and range, and you're familiar with it because you know that when we make our t-chart, X and Y, we can replace this with the term input, output. We just learned independent and dependent, and you've known for quite a while this is the domain and this is the range. You've probably known that from previous math classes. So there's a lot of different terms for that X and Y, and we're focusing on domain and range here. You should take the time to read this scenario. And what's happening is we have a $60 gift card, and it's for a movie theater, and every time you go to a movie, you lose $10 off the gift card because you just paid for the movie. So we get the remaining value on the card is $60 minus $10 per movie. And since you're now becoming a pro at function notation, you could call this R of M equals 60 minus 10M. Well, you know that the domain is the input and the range is the output. And we're going to apply that to this scenario. And when we look at this, we think about what would be a reasonable domain. Well, remember, the domain is the input And in this case, we're going to input for m, the variable m, and we're going to get an output of the remaining value on the card. So input the number of movies, output the remaining value, and when you think about that, you come up with the idea that there's really only a certain set of numbers that are reasonable for this domain. Since this card only has $60 on it, once I get to 6 movies, I've used up the entire card because they're $10 a piece. So a reasonable domain goes from 0 to about 6. It'd be silly to try to plug in, say, a 20 into this chart because you can't go to 20 movies if you only had $60 on your card. So sometimes we will write out the domain as a list like that. That's totally fine. Sometimes we'll use inequalities like this. This is saying m is bigger than 0, but less than or equal to 6. So I could go to 0 movies, and I could go to up to 6 movies. A reasonable domain in this case is 0 to 6. So if there's my domain, I can plug into my function and get out a range. The range is the y values, or the output. And we can take these and graph them, and we get a graph that shows you the declining nature of your movie card. If I went to 2 movies, I would have $40 remaining on my card. That's what it says right there as well. If I went to 5 movies, I would have $10 remaining on my card. So this part is the range. You see it on the y-axis, or that's also called the dependent axis, and we can list that range, just like we did with the domain, as a list or as an inequality. The value is at least 0 and can't be any bigger than 60. We're going to take a look at these questions here at the bottom in a moment, but I'm going to take a short detour and talk a little bit more about the domain and the range. Because we saw it there in one way, but I'm going to show you that there's many different ways that you might end up seeing the domain and the range. So here's a table. That would be pretty easy for you to say, hey, that's the domain, that's the range. No big deal. But it could come to you in ordered pairs. In the ordered pairs, you have x comma y, and now you have to do a little bit more work. If I wanted to know the domain of this relation or this function, I would have to find the x value of each of these. So in this case, I could say the domain is -2, 0, 2, and 3 by just picking out the x values. And then I could say the range is -1, -5. There's another -1. I'm just not going to list it again. And 4, which, by the way, finding the domain and the range from these ordered pairs is the same thing as I had in this table. If I look at this graph, each one of these points, which, by the way, comes from this table, has an x value and a y value. So this is the point -2, -1. This is the point 0, -5, and I can do that for all these points. So by doing that, it's again more work, but I can figure out what the domain and the range is by doing that work and saying the domain is this, 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 and this, because they're the x values. The range is this, 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 and this, because they're the y values. So whether it's given to you as a table, ordered pairs, graph, or other tricky ways, you should be able to figure out what the domain and the range are. All right, let's go back and finish out that scenario that we took a detour from. We were back at the movie card scenario where if I went to 0 movies, there was $60 on the card, and as I went to more movies, the card's value went down to 0. Now, the number of movies, by the way, this is going to be a discrete variable because you can't pay for part of a movie. So in this case, we had a y-intercept. It was up there, way up there. That's where this graph hits the y-axis. What does it represent in the scenario? Well, that spot, that 60, was the original value on the card because the card was loaded for $60. The graph meanders along and eventually hits the x-axis. There's an x-intercept, just like that was the y-intercept. And what does the x-intercept represent? The x-intercept represents the 6th movie, and that's when the card value went to 0. If I look back up at that graph, I've got the x-axis and the y-axis, independent, dependent, domain, range, input, output. So when they ask me what's the independent variable, it's the one from the x-axis. What's the dependent variable? It's the one from the y-axis. And as I mentioned, oh my gosh, who spelled that? We have discrete data here because you can't go to part of a movie. You can only go to one whole movie or not. Or at least you can pay for one whole movie or not. I guess you can leave if you want. Okay, there's a lot of vocabulary there. You have this note sheet, and this note sheet is something that's going to be good to review as you're going through the homework or studying for a quiz or a test, because you can go right down these bullet points and go through the sheet and reacquaint yourself with each of those terms.